Hi, this is Javier Encinas. This is a quick overview of the basic capabilities of ASDIP Concrete, our software for design of structural concrete members. When you open ASDIP Concrete, the project manager shows up. From here you can open and create your calculations, and you can specify your settings and save your work and so on. In this version, 3 modules are included: concrete columns, concrete beams, and bearing walls. Let's start with the first module, concrete column. Let's assign a name, any name. The name is added to the tree. Double click on that and the calculations opens. Alright, the user interface is very efficient. It has been designed to model your structure the easiest way. It consists of controls such as buttons, labels, text boxes, combo boxes, etc. So it's a very rich user interface. The typical calculation window is composed of the menu bar at the top, and immediately below is the toolbar. From here you can get access to basic commands of the program. Below that is the working area. It's composed of 2 tab panes. The left pane is dedicated and designed for the input data, and the right pane is dedicated to the results of the calculations. It's very efficient. The tabs are organized in such a way that is a logical input of the data to avoid confusion. For example, in the geometry, you can specify all the dimensions of your columns. The column type could be rectangular or round. You see that the images changed accordingly to simplify the input. So you can input here the dimensions, the width and the height, the rebars, the reinforcement, and the ties as well, the concrete cover, and slenderness, which includes the length of the column and the effective length factors. Here you have a quick explanation of typical K factors. Lateral stability, if the column is sway or non-sway, meaning that if it's part of the lateral resistance system or not. Materials, here you specify the material properties for concrete and reinforcing steel. You have 2 options for Hohnstatt, which is the parabolic curve, or Whitney, which is a simplified rectangular equivalent block. For steel, you have elastoplastic, which is this graph here, or the strain hardening, which is with this additional capacity at the end of the strain range. The loads. Here you can specify the column is biaxial or uniaxial. If it's biaxial, you can see, for example, the diagram. You can see the 3D diagram that shows up. If it's uniaxial, it's only a 2D diagram that is generated. The loads can be either nominal set of load cases, such as dead, live, snow, wind, seismic, etc., or could be a pre-combined, meaning if you already have your loads already pre-combined in your column. Say, for example, that is part of the output of another software and analysis software that you have, and you have the loads in the column. Well, you can specify them here. They are already pre-combined, or you can specify, as I said, the load cases, and the program internally combine them. In the second order moments, could be the second order analysis. In this case, no further magnification is necessary because they are already considering the P delta effects and all that. If not, if it's only the first order analysis, then it's necessary to magnify the moments accordingly to the ACI method. Here, show parameters. It shows all the necessary fields for the amplified, magnified moments, magnification method in the ACI. This changes accordingly, depending if it's sway or non-sway. For example, for non-sway, you go back to the parameters. This table is different to the one you saw before because it's for non-sway. So the program is internally smart enough to specify the correct table according to the kind of column that you're designing. Here in the calculation side, you can see at a glance, in just one screen, you can see the main results. For example, you can see here that 3 load combinations are failing. This indicates it fails, meaning that the capacity is not good enough for the loads applied in these 3 combinations. The interaction diagram and the column strength. Here in the condense tab, you can see the same results, but with more detailing. More involved, with more information provided. And in the detail tab, it's even more detailed information with all the calculations, the formulas exposed, and reference to the ACI code. As you can see here, all the formulas are exposed. So it's a very efficient way to follow the calculations. In the diagrams, well, you can see the interaction diagram that is generated. For example, for biaxial, you can see the 2D and the 3D diagrams. Here you can specify the angle of rotation, this angle theta, that for theta for rotation. You can specify also if you see only the PNMN or not diagram, or just the affected portion for phi, the splicing areas, and the applied loads. Okay, the combinations, you can specify here the units, US units, or kilonewtons, or megapascals and SI units, or MKS, which is tons and kilograms per square centimeters. The combinations is ASE 7, either 10 or 05. You specify which one you want, service and factor combinations. And the program internally follow the combinations accordingly. The reports, print preview, you can see the condensed report similar to the condensed tab here, but including all the images. Page 1. Okay, so this is a nice pre-formatted report that you can just print out and show to your clients or your checker. You go to the detailed report. Same thing, page 1, page 2, page 3, page 4. You can see all of them together. This is a very nice pre-formatted report that you can print out again. So this is the concrete column module. Let's go back to the project manager and open a concrete beam quickly. Assign a calculation name, add. The name was added to the tree here. Double click, and this is the concrete beam module calculation sheet. Similar layout, similar environment that you are familiar with. In the geometry, you can specify the beam type, the section type, rectangular T-beam, spandrel beam, inverted T, or L-beam. Okay, and here you specify the dimensions depending of the type of beam section that you are using. Here, the number of support. This is a module for continuous beam up to 6 support, which means 5 spans and 2 cantilevers. You specify the dimensions of the spans over here in this table, and the type of support. In the materials, similar to the previous module, you specify the concrete and the steel properties. In loads, again, you can specify either a single set of pre-combined calculations, pre-combined loads, or a nominal set of load cases, and the program internally combines them. It's either uniform loads and concentrated loads per span and per segment. For example, in this case we specify, for example, 3 supports. It's a two span beam. Say, for example, let's say 4. So 3 spans. Let's add one more span, say 15 feet or something. Change this to be different. Say 18 feet, something like that. So we have a 3 span. Okay, let's go to the load tab. So we have now the 3 spans that we just defined. For span 1, we specify here the load that you want. For example, you want to specify for the full length of the span number 1, which is 10 feet long, say 1 kip per foot, and let's say the 3 feet. Let's specify a live load of 10 kips, something like that. Okay. Here you can copy all these loads to all sides. Let's do that just to see. In the graph, I'm checking graphically how the beam looks. This is what we specify right now. So something like this. Okay. And this is for load combinations also. And per segment, I can just focus on the first span or the second span or all of them. The program internally calculates the moments. It has an analysis portion that defines all the moments and shears along the beam, and also we have a construction area. Also is per segment. Let's say all of them. You can specify all these rebars here in the reinforcement area. For say, for example, for the span number 3, we go to span number 3 and specify different. Okay, let's say I'm going to use 2 rebar numbers 5 times 5 feet, so it shows up here. So whatever you specify in this area is reflected graphically in the charts at the right. And the program, of course, uses all these numbers, all this information to calculate the capacity of the beam. At a glance, you can see in just one screen all the main information. You can see if the beam passes the parameters. For example, for bending, in this case, passes perfectly, no problem. In shear, it passes as well. All the reinforcement parameters pass. So this design is okay. You can optimize it, of course, if you want, just changing here and there and modifying different things and optimize your design. In the condensed tab, you can see the design as well, but with more detail. The same bending that we know that pass, and bending strength. Here is the shear forces. We know that pass, and all that. Deflections is calculated. Well, in this case, it's very small, so we need to increase the loads and all that. But this is just an example to see very quickly how the program works and how the program reports the calculations and the results. In the detail tab, you can see the results, but in much greater detail with all the formulas exposed and reference to the ACI code. There's a lot of information how the diagrams are created, or how the capacity, the shear, and the bending. And finally, the deflections and all that. So everything is reported here. And of course, you can create your reports as we saw previously. For example, the detailed report, you can see all that. Let's see all the pages. yeah, let's see, 4 pages, we have more pages, six pages, yeah, you see the report. So it's very nicely pre-formatted, so you can print out all these pages, and it's part of your calculation set. Let's go to the last module. This is for bearing walls, arrow plane. Let's click on that, add the name to the tree, double click. Okay, this is a module calculation sheet for the wall design. Same environment, same thing that you already know. Input here, output there. Geometry. Here you specify the wall thickness and the rebars in on the wall, including the cover and all that. Slenderness, of course, the length of the wall, and the K factor, the effective length K factor. The condition, if it's continues the way up or stops here or it has a parapet or this kind of stuff. Materials, already you know that concrete and steel properties. In loads, here you specify dead, live, and load, roof, snow or wind in the wall with eccentricities and all that according to these images at the bottom. You see that the second order moments show parameters similar to the column that we saw before, but specific for the wall case, which is slender, narrow. So the program magnifies the moments if necessary. In the right side, we can see here the results in the right pane. At a glance, in one screen, you can see all the amplified loads. All of them pass, so the design is okay now, and you can see it graphically as well. Yeah, all the loads are inside the usable area. So this is a very small portion that is used, so everything passes and it's okay. But in some cases, these loads may go outside of the usable area and is not acceptable. So all this needs to be checked. In the condensed tab, same thing, same result, same calculation, but with more detail, with more information provided, all the parameters and all that. In the detail tab, same calculations, but with all the formulas exposed. That depends on the degree of, the level of detailing that you are looking for. You just check very quickly. Okay, it passes. That's it. You want more detail? Go to the condense, and you can see the most important parameters there. You want full detail? Okay. You have all the formulas and all the detailing here. You can go step by step and check everything graphically. You can see the diagrams that the program generates, the interaction diagram for the wall. This is a typical, for example, a tilt-up wall in a warehouse, for example, looks like that. So you can design this kind of walls very quickly with ASDIP Concrete. Go back to the project manager, and with this we conclude this video. Thank you for your attention. We'll see you in the next video. Thank you very much.